Hi, I am so excited to be back. Hello, everybody. I'm Anjana Vakil, and I am just first of all so happy to be back at Bang Bang Con and watching these already amazing talks. Huge props to the speakers that have just spoken, and I hope you're ready for something silly and a little bit different because that is what I got for you today. So, this is a weird experimental adventure into the lambda calculus that I have pre-recorded to avoid any potential audio issues. So let me try to get that going for y'all here. And I hope you're ready for weirdness because that is what's in store. Imagine a function, simple and pure, one value returned, a simple abstraction, Alonzo Church called a lambda. The symbol for lambda, you've seen it before, 'cause the lambda calculus is FP at its core. From this simple abstraction, we get Turing complete computation. But how do lambdas work? That's what we'll find out today. You won't use them at work. Whoa, what can I say? But they can help you learn why functional programming's right. Imagine a function takes x gives x squared. It's called abstraction. When the function's declared, when you call it on a value, we call that application. Now let's dissect the parts. Lambda symbol, parameter, dot. The rest is what's returned. That's all a lambda's got. Just one input, one output, no side effects. Now let's see what they can do. La 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 lambda. La 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 lambda calculus. Hello friends, and welcome to La-La-Lambda calculus, a musical, functional journey deep into the heart of functional programming. The sweet, sweet soundtrack you're listening to today is courtesy Joseph Griffith, aka DJ Magnetic Dozer. You can find his work at peachstapler.com. We're listening to select tracks from When the Bytes Go Down in the City, an 8-bit musical tribute to Journey. As for me, I'm your host, Anjana Vakil, aka DJ Vakila on GitHub, and we're at Bang Bang Con 2022, the most joyful conference around. Special shout out to our sponsor, Alonzo Church, aka DJ Algorithm, for the hot functions we're looking at today. Thank you all so much for being here with me today, and I do hope you'll enjoy this musical, functional journey. One input's not really a lot to write a program with. What do we do if we need to, like to add y to x? It's alright, hold tight, Alonzo's got a fix. One function returns another one, that one returns the sum. Oh, because functions are just values, we can pass them around as inputs and outputs. Or to say it fancy, lambda calculus has functions that are first Let's say that we want to add 3 to 5 functionally. We apply left to right, so x becomes a 3. Then the y becomes 5 upon the next apply. Now our sum's almost done, and here begins the fun. See, there's just one tiny problem. We don't have addition, we only have functions. Here's another stumper. We don't even have numbers, we only have functions. Wait, hold on, hold on, hold on, hold on. It sounds kind of gone, so but our friend Alonso made this innovation. If we need to count, we tally the amount of function applications. Apply a function once, we can call that 1. 2 if it is twice applied, and so forth and so on. Now we can make functions we could call the number kind. They have such a shape, some function f they take, and they return a function where whatever x we give it, f is called upon it however many times we care. Now we have a functional entity that's countable called a church numeral. Now all we gotta do to use our new numerals is make an operator that adds together numerals, and if we can make it, we'll have a lovely funeral. Just a simple task, really not a lot to ask. Build out a function's all that a program needs. Just a simple plus, how hard could it be for us to build an operator that gives us some? If M is here and N is there, then there's sums of function where the total times that F gets applied is the M and then the N again. Numerals adding up to make another numeral. Its shape is the same as we have seen before. First we call N, so F gets applied N times, and then we call F N more times. Working hard to build our plus, Alonso found a way for us to represent any construct we need as just one more fun. For example, take true and false. They go hand in hand with if then else. Then an else branches present a choice, and we choose one with a boolean. Pick false, and if it's false, pick true. And works much the same way. If A is true, then B's in play. But if A is false, just return A. Don't stop encoding. If we want pure functional programming, we must lambda all the things. Don't stop encoding. Church is key that we're now holding. Data as behavior for the win. Don't stop encoding. Keep on with that lambda ending. Abstract and apply those functions on and on and on.
Thank you all so much for having me and for indulging me in this ridiculous.
Oh my gosh. Thank you for creating that. That was beautiful.
Lambda all the things.